Okay.
Okay.
Go ahead, Yuvi.
Yeah, I'm gonna send a link to the slides I'm using on the chat, so people can click the links there and stuff if they need to.
Okay.
Can you still see my screen?
Yes.
Is there a different screen now? Can you see my slides?
Yes. Multi-user notebooks on the cloud.
Yes. Every time I get this to work properly on the Linux, I'm very happy.
Okay.
Okay, so hello, thank you for setting this up. That was a good introduction. I'm Yuvi. I am a developer at Project Jupyter. I mostly work on making it very easy for people to deploy and maintain really large installations of JupyterHub. And by really large right now, it's like a few thousand users once, but we're trying to push that envelope to be larger. So I currently work at UC Berkeley. I built infrastructure for them doing data science for undergraduates in a way that they don't have to install stuff on their local machine and keep asking their PAs like, hey, this doesn't work. I can't install Python. What do I do? Over and over again. Let me get rid of these notifications.
Oh yeah. Go ahead and take care of that.
Yeah. It's like, I'm gonna stop. Okay. Feel free to, I'm going to go through a few slides and then I'm going to jump into a demo, but at any point feel free to stop me and ask clarifying questions. The demo is also going to be quite fast, partially I think because we've made installing this a lot easier, but if a lot of it is I'm just following the guide that I'll be introducing later, so if whatever is unclear, you can follow this along the guide later or just stop and immediately ask me.
Yeah.
Right, so next slide. Right, so Jupyter Notebooks, I'm going to assume that everyone kind of already knows what Jupyter Notebooks are, but I had a small demo prepared anyway, which is the LIGO gravitational wave study. They have been, the LIGO people have released a bunch of notebooks which is how they did their analysis, and we have them running. So if you see my screen now, you can see that it's a narrative document that has, both text and code that you can run, and also visualizations from the code and no results from the data and things like that that you can play with. So it's a way to reproduce what they've done, but also to explain what they've done. So many people think of this as you're just doing exploratory work, but then you can package it up in a way that makes sense for other people as well, and also makes it much easier for them to modify. If I want to see, if I want to just change this plot and see how this looks like, it's much easier for me to just do it right here, and also surrounded by the explanation of what they were trying to do, rather than having to recreate it from scratch myself.
You can
of course,
hide
there's
that.
tons of uses for this.
Hide that thing at the.
Oh, there's a thing at the bottom.
There we go.
It doesn't seem to go away though.
Oh no. Okay. Never mind. Keep going. Sorry.
Yeah. Yeah. I think it's. Oh well.
Who cares?
That's the Linux. It's my excuse for all of these things. Okay. So let's just look into your notebook. I'm just going to move on from there. I'm guessing that we are successful enough that everyone knows about us.
Yeah.
Yeah. So JupyterHub. So notebooks still have some problems. If you are installing them on your local machine, they're great. But then you're still installing them on your local machine, and depending on what your local machine is, this could be difficult. If you're running Windows, or if you're running a slightly older version of something, or if you just you just want to have 34 gigs of RAM and access to a really fast Hadoop cluster, or there's a million reasons that you might not want to actually install this and run this on your local machine. I think installing software is something that on desktops at least is still many years behind, and we shouldn't require people who are experts in their field to have to learn how the Python Windows installer works, or what C libraries you need before they can do their work. So JupyterHub is a way to do this on a multi-user setting. It's used in a lot of classrooms, research projects, workshops, and whatever. But the user experience primarily is you go to a website, you go to a URL, and then you log in with some authenticator, and you basically have a computation environment there for you. And you can use many different kind of spawners. So if you already have a cluster running, like Slurm or Grid Engine or Kubernetes, or you just have a big machine with systemd or like just plain process running, you can set it up, and there's also like various authenticators. So if you're already using some authenticator at wherever you're working at, you can just like keep that and use it so that you can provide access to just a whitelist, or like it's very configurable. You can do whatever you want. I'm going to show you a short demo of this so you can understand the workflow. So I used to work at Wikimedia, and we have a publicly available JupyterHub instance for people to play with media Wikidata. So if people are writing bots or like doing any data analysis about things that are related to Wikipedia, they have access to this. So you just go to this website, which is pause.wmflabs.org, and we have it set up so it's using the Kubernetes spawner. Kubernetes is a cluster scheduler, not very dissimilar to like Slurm, but much better and much more newer. And we are using it to, like, you sign in with your Wikipedia account. So I just click sign in. It redirects me to like an OAuth permission screen, and then I click allow. And it basically then takes me to my notebook. This is my workspace. I have been using this for a bunch of things. In fact, the slides you saw were actually created here. Like the slides are in a notebook that I'm using to make the slides, and these are like just random other things I've done. So these are not on my computer. And I also, from here, have direct access to like the MySQL databases that are being used in Wikipedia and things like that. So I can, which I don't have on my laptop because it's multiple terabytes. So by giving me like a computation environment that's closer to the data, I can do more things, and I can also like interact with other people. The link I sent you, for example, on the chat is actually a public view of this. So it's very easy for me to like share my work with other people and keep it in one place instead of having to go through like a publish and get back like a GitHub workflow where I'm like pushing and pulling all the time. Notebooks also come with the terminal by default, so this is also a good alternative to SSH for a lot of people, especially if you're on Windows, because I think this terminal is actually better than the Windows terminal, and just like set up by default with a bunch of useful stuff, and you can do a lot of things in it. So I think this is very important and transformational technology for the future. Like in 10, 15 years, I think a lot more people will be doing their work in this fashion than on their laptops. And I think like the way that Chromebooks have transformed like K-12 education in the US by the fact that you can grab any of them and all of your work is in the cloud, so it doesn't really matter, and your machine becomes like kind of interchangeable, and that has had like some really positive effects. I think we will see similar effects from here, but because you can run your own JupyterHub, you're not as reliant on one entity like Google, which could do whatever it wants with your data. In this case, you control your own data and you can do what you want with it.
Cool.
So that's the. Was that a question?
No, I was just saying cool.
Yeah, awesome. It is pretty cool. Because I've been doing this for a while, sometimes I forget how cool it is. So it's always good to know. Anyway, so going back, that's the demo of what JupyterHub is and why it's important, when you can just run it on your local machine. Okay. Well, let me just fix this. This is a notebook, so I'm going to go and change this so that, that's better. Right. Yep. So the primary thing I'm going to talk about is the Zero to JupyterHub guide. You can go to that URL. It's Z2JH, which is zero to JupyterHub.jupyter.org. It'll redirect you to this documentation page. We are trying to form like a somewhat opinionated but follows best practices from industry and academia guide that lets you set up a JupyterHub very quickly. As you were saying, it's sometimes very difficult to set up because it has a lot of moving parts because it is so configurable. So this is like a distribution of it that has like a bunch of parts we pre-picked for you, and that have like a lot of advantages. So it's currently used, like lots of people do this for workshops. Like you can set up a JupyterHub in like 20 minutes with this and scale it up and down pretty quickly. So when people do a workshop, instead of like trying to get everyone to like install Python and random libraries on their computer, we just help them like they just like self-service set up a JupyterHub for their workshop, and then they can tear it down at the end, and they'll also like make sure they have their materials and stuff in it. UC Berkeley has a data science program that's targeted primarily at students who don't take computer science courses otherwise. That is using JupyterHub, and like does exactly the same distribution. So we can manage a large number of students without having to deal with like installation, troubleshooting on their local computers. It also lets us do a bunch more things, like make it easier to do homework distribution and collection because it's like in one there. And Wikimedia, we make it so that like people can access we have a lot of open data, but it's not very easily accessible because the Wikipedia dumps are like 5 terabytes or something, and our MySQL database is also really big. So you can't really download it on your local machine and go, while this makes it really easy for you to just instantly access the data. So there's like lots of use cases here, but these are some of the places where it's currently being used. And we're always looking for more people to try it out. Some of the features of this are it's a fully reproducible infrastructure. So we have a YAML file, which is a kind of markup file that is translatable to JSON very easily, but much more easier for people to write. It fully captures the state of the cluster. So the example I use for this is about 2 months ago, one of the Jupyter hubs I maintain died because the people responsible for paying the bill kind of forgot, and it was there was a screw up. Then Google just pulled the plug at some point, and all of our computers were like basically destroyed. And then we figured this out immediately because we had an alert, and then we went and then we paid the bill, and everything just came back up. We didn't have to do anything because like we had basically made our infrastructure completely reproducible. So this event basically forced us to exercise all of the things that we had been saying, which is like, oh yeah, it's fully reproducible, you can turn it down and bring it back up. And it was toned down and it came back up, and like everything was fine. They hadn't deleted any of the user's data, so that was fine. And all of the infrastructure just came up. And that's because like we built this to be fully reproducible. So, and we keep these YAML files in a Git repository, so we can also do other things with it. Like if we make a change and then it's like, oh, this is actually screwed up, we can easily revert, because you just revert the state of the Git repository and then you do deploy again, and it works fine. This lets us do like continuous deployments. So earlier, like oh, I need a new library in this environment, or like we need to give people more memory. So it might take like, oh, we'll take down this cluster on like the Sunday and then redo it, or it might be like a more like it's not like an easy operation, but because it's fully reproducible, we have like multiple clusters. So we have a staging cluster that's exactly the same as our production cluster, except smaller, but identical in every other aspect. So we can always deploy to that and then be like, oh yeah, that worked. And like 99.99% of the time, that if it works in staging, it will work in production. So you can deploy without like wondering if it's going to interrupt people's workflows. And the users who are actually seeing, like who are actually using JupyterHub at the time won't actually notice any difference. Except for the actual change you made. So if you give them more RAM, they'll have more RAM, but you won't disrupt them otherwise. And it's also like cloud/provider agnostic. So we have it running on Google Cloud, we have it running on Azure, we have it running on Wikimedia's like own cluster that's like just a bunch of machines in a data center. We are also running it on a couple of other like random data centers like at Berkeley, all on the same thing, because it's very nicely layered. And it uses like Kubernetes, which I'll come to later. So we don't actually have to like have an AWS specific deployment, a Google specific deployment, and like a like data center specific deployment. It's also nicely layered. It doesn't have too much magic. So when it breaks in ways you can debug. This is always a problem, I think, with lots of solutions that promise that you would have an easy way to like deploy something that's like kind of complex, but also we'll simplify this into one command, and then like it works when the one command works, and when it doesn't work, it just breaks in like these like strange ways that you don't know how to debug. We try explicitly to not have that be a thing. We try to make sure that what we do is like best practice in the communities that we are doing them in. So if you're deploying this and something breaks, you can always like talk to us or to the Kubernetes community, because we are deploying this on top of Kubernetes and using their best practices. And so anyone who can debug any Kubernetes problem can also debug this. So these are just some of the things we keep in mind when we build this. And why Kubernetes? Kubernetes is the scheduler that we have picked for this installation. It's very nice. I'm a big fan. I worked with like Grid Engine and like Docker and a bunch of other things before, and I like this a lot. It provides very high-level abstractions that are quite non-leaky. While like it's not just like run a process for me on this cluster. You can say things like, run this process and make sure that it is always passing its health check, and if the health check is not passing, then restart it. Or like I just want to talk to another process that provides me a hub service. I don't actually care which node it is on or how many of them are running. So it provides a lot of really high-level abstractions that are like quite non-leaky. So you can like rely on them without having to like, oh yeah, but this will only work if it's on the same node, or this will only work if those nodes are on the same data center, or things like that. Like where these abstractions don't seem to have very nice, like they seem very nicely built, so they don't seem to like break in unexpected ways. It also abstracts away most of the underlying hardware while still allowing the hardware to be taken advantage of. So if you have 5 machines and some of them have like 30 gigs of RAM and some of them have 3 gigs of RAM, you can put them all in a Kubernetes cluster and it'll schedule everything appropriately. But if you have a couple of machines that have fast SSDs and some that have GPUs, and you have jobs that require to be run on them, you can easily say like, okay, these kind of jobs will run here and these will run here, without so you get both the advantage of homogenizing. So you are dealing with one API and one set of concepts, but you can set up a heterogeneous cluster with this. So you're not like having to like have all of the machines be the same. It's fairly self-healing. We haven't like once we set it up, we don't like really have any problems. Usually if we had an outage, it's because we deployed something and it ran into an issue. And then we usually catch these in the staging stage, and we just like write an incident report and then be like, okay, we'll fix this in this way, and users rarely get affected. It also has an amazingly fast-growing community. They merge like 150 commits a day. They have like hundreds of companies contributing to this. It's a really nice open source project that's under the Linux Foundation. So it's not like some random companies like like, oh yeah, we made this, use this, and then pay us for the enterprise license thing. So I really like that as well. So that's why we picked Kubernetes. You can go to kubernetes.io to learn more about that. They also have written a paper. Google wrote a paper on the things that they had built in their previous container schedulers and how that informed Kubernetes design, and it's a very nice read. I highly recommend it. Okay, so I'm going to stop now, and then I'm going to jump directly into a demo. Do people have questions before I go there? No. Okay. Okay. So I'm going to go into a demo. Can people still see my screen?
Yeah, I had one question actually.
Yes.
You mentioned several different cloud architectures. Is OpenStack also? I mean, I guess if Kubernetes runs on OpenStack, I guess the answer is yes. Then, right?
Yeah, it is.
Okay.
Yeah, there is also some OpenStack integrations that you can use if you want. If you're using Neutron, I think it integrates directly into that, but you don't have to use that. You can just treat OpenStack as like a, like just as the same as bare metal install, and it'll just work on there as well. So,
okay.
Yeah, and if you have a full set with, like, say, for example, Ceph or Swift installed as well, rather than just Nova, it'll integrate with that as well, and you can use your Ceph for storage and things like that.
Okay. Good.
Any other questions?
Hold on a second. I realize I muted people. Does anybody else want to ask a question? Okay, go ahead.
Okay. So can people see my terminal? Is the font size okay? Is the colors okay? Should I change any of them?
No, it looks good, although the last line is, of course, partially hidden by the...
Right.
Maybe you can...
there it is. That's better.
Oh, good. There we go.
Okay.
Somewhere.
That's really weird. Yeah, okay.
Yeah, that's good.
Okay. So I'm going to be using Google Cloud for this demo, simply because I have credits there, and like that's the one I have most experience with. I pre-created this cluster because this takes like 3-4 minutes to come up. But you can see that I was just doing, like I'm creating a cluster called ESIP-demo. I want the version to be 1.614. So this is creating a Kubernetes cluster. And I've created it with 3 nodes and of machine type N1 high mem 2. I think it has 15 gigs of RAM and 2 CPUs. And like now we have 3 of these nodes.
So it doesn't say Kubernetes anywhere, but that's just the default with the Google Cloud, or is that?
Yeah, exactly. Yeah, it's if you are using Azure, you would do ACS and create, and if you're doing OpenStack, you would do whatever was your when we did OpenStack with Media, we used Puppet to control that, so we would apply Puppet roles to set up Kubernetes, and I think there's also like a direct integration project with OpenStack that lets you just create an OpenStack object that ends up being a Kubernetes cluster. Okay. So this part is like specific to where your Kubernetes cluster is going to be set up. And in our case, it's Google Cloud.
Yeah.
So that's the gcloud command, which is the command line interface to Google Cloud. We won't be using that too much. Then there is kubectl, which is the Kubernetes control, which is the Kubernetes client. So Kubernetes has a HTTP API that's like very nicely REST, and you can use that with like whatever you want, like lots of language bindings and whatnot. But kubectl is the command line client that you use for interacting with it, like manually and whatnot. So when you do gcloud create, it automatically gets credentials and stuff for you. So I can do kubectl get node, and it'll tell me that I have 3 nodes. Yeah, I think my internet is saturating with the video, so it's like maybe slightly laggy, so hope that's okay.
Yep.
So this kubectl is not Google specific. So if you have a cluster running on OpenStack or on Azure or on your own data center, you will still be using kubectl. So everything I'm doing with kubectl or Helm, which I'll introduce in a bit, are not Google Cloud specific. So you can mostly forget the fact that this is running in Google Cloud.
Cool.
So cool. So we have 3 nodes running. So I'm going to install something called as Helm. So Helm is a package manager for Kubernetes. So the way I can think of it is like it's like dpkg or like apt or yum, but for a distributed system that runs across like many different nodes on a Kubernetes cluster, which is what JupyterHub is, right? We have multiple components and they're like doing a bunch of complex stuff. And this Helm is the official package manager of Kubernetes. They have a bunch of other things that you can install with it. You can install like MySQL or like Hadoop or Spark or Dask or whatever. Like just like how someone takes a software package and then packages it for Debian or Yum, people take like random software packages and package it for running on Kubernetes using Helm. And that's what you've done with JupyterHub. We created a chart that lets people install it and configure it in a specific way. Helm is also not specific to gcloud. It's just like a Kubernetes application that talks to the Kubernetes cluster to do what it wants. So I've done Helm init, which sets up Helm on the cluster. And if I do Helm list, it'll basically give me back nothing because I don't actually have anything running on the cluster right now. So what I'm going to do is I'm going to create a directory. Oh, I already created it. Empty. And I am now going to go to the guide. So I've just pre-done a bunch of these steps. It's like creating a Kubernetes cluster, talks about how to set it up on gcloud, setting up Helm, I already did that, and I'm going to go to set up JupyterHub. So you have to create a file called config.yaml and give it a couple of secrets. So config.yaml. We need a cookie secret because the hub uses cookies for its authentication. Secret, and we just generate this OpenSSL rand hex. And then a secret for another. This is a secret for letting 2 of the JupyterHub components talk to each other. Now, this is the entire state of our JupyterHub cluster. we're basically saying these are going to be the secrets that we're going to use, and everything else, give us the defaults. And I am just going to install it now. I'm just going to copy paste this line. There we go. So I'm doing Helm install and the full path to our last release. We will eventually make this shorter, so you can simply do like, JupyterHub /0.3.1 instead of the full path. But right now we have to use the full path. And I'm going to give it a name. I'm going to call it ESIP demo. If I'm setting this up for a class, I will probably give the class the name be the same as the name of the class. So just for me to deal with upgrades or like figure out what's going on later. And then you specify a namespace as well. So namespaces are a Kubernetes feature that are nice units of access control and like isolation. So you can say things like, this user has access to this namespace inside which they can use a maximum of like 30 processes and 20 containers of like maximum 20 gigs of RAM or something like that. And it's also useful to manage things. So you can like, I'm going to get rid of this namespace, which will delete everything inside it. And it also makes it easy for us to like organize things. So it's just like units of organizing. And then I'm going to -f config.yaml. So I'm saying install JupyterHub, use this particular config. Then I'm going to hit enter. And then I'm going to wait. This will take a few minutes because it's pulling all of the user containers on the 3 nodes, and it's like setting all of these things up. It's usually faster when you do an upgrade.
So just while we're waiting here, I think most people can get something like 300 units of free Google Cloud, right? Something like that, $300 or...
Yeah, everyone has access to $300 of free Google credits, which is actually what we use when people run workshops, because even if you run a week workshop, it's not going to be that much money. So, yeah.
Cool.
You do have $300 of free Google credits. There's also $250 of free Azure credits. So, if you run out of this and you're like, oh, I just need to do something right now, then you can use that. So, you can like kind of hop around and for a while. So, cool. I'm not recommending that, dear cloud providers who might be listening, but it's an option.
Yeah.
Okay, so now this is set up, and we can check it out. So I can do namespace equals to ESIP demo, get pod. So kubectl is like fairly well designed, I think. It's always, you have a verb, and then you have a noun. So in this case, the verb is get, and the noun is pod. So I'm like, give me all the pods. So pods are the equivalent of containers, except they have a bunch of more features. They can be attached to volumes. You can have multiple containers in the same pod, which is usually used, in a case like you have an application that needs authentication but doesn't do authentication itself. So you can put Apache in front of it, make Apache do the LDAP path, and then just leave the application as is. Application just listens on localhost, and Apache can connect to it on localhost. Nobody else can. So it's a very nice, useful abstraction that gives you a lot more than just directly using containers. So a pod is composed of containers, but in our case they're all just single containers, but we call them pods. So if you're used to Docker, you can just think of them as like a one-to-one mapping, and it mostly works out.
So get pod is sort of like run, is like Docker run in a way.
Get pod is like Docker PS.
Ah, okay.
Because it just tells you what's running.
Oh,
not actually doing any actions.
Okay.
And in the same way, if I do get service, it tells me all of the services I have. So a service gives you a stable IP to a group of pods. So these pods, these containers can be running on any of the 3 nodes. But we want to have like a stable IP that we can refer to them with. And that's a service. So a service would just, so the hub service, that IP will always refer to the hub pod no matter which node it's on. And same for the proxy API. So we have 3 services. The hub is how the proxy talks to the hub. And the proxy API is how the hub talks to the proxy. And the proxy public is where us users can like go and see things. So I've just asked it for an external IP, so you can see an external IP. So I'm just going to go to the external IP right now. so you can see that it already just works. So if you basically install JupyterHub in a way that works out of the box, we have the default settings are a dummy authenticator, so I can go in with any username and any password. Of course, don't actually do this for production instances. But if I come back here to the terminal and do get pod, you will see that it is actually creating a container for me. It says it's in container creating. If I do watch on this, I can see that JupyterHub has created the container and it's running, and I can go back here and it's up. So I can do things here now. So this is a big difference than how it used to be. We basically created an entire JupyterHub cluster that is fairly solid. It has like pretty good defaults in like a few minutes. And this used to take a lot longer before, and it is like, this is also like very easy to upgrade and whatnot. So I can just, I can create a new terminal, I can create a new notebook, I can like do whatever, it's just like a Jupyter notebook running on a remote cluster, and everyone else can access it too if they go to the IP. So yeah, I can do hello, and this comes with persistent storage by default. So if I go to my control panel, let me save this. I'll save. And if I go to my control panel and then I stop my server, and you'll see that that pod is no longer running. It's being stopped. And if I start it again, it'll come back, and then my files will still be there. So it's so the file I created is already here, and I didn't actually have to do anything. This is all set up for us by the fact that we created a Kubernetes cluster. So all you need to do is to find someone who will set up a Kubernetes cluster for you. And if like the similar way, if you're running OpenStack, someone needs to maintain the OpenStack infrastructure, and in the same way, someone needs to maintain this Kubernetes infrastructure. And on top of that, you can do all of these things, and it's very nice and easy.
You see the message in the question in the chat?
No, I did not. Let me go see that now. Oh, right. So, sorry, I'm just going to grab some water. Right, there's a question which says, does one need to use Helm to install packages, or can they use something like Conda? So that's the next question. That's the next part of the demo I'm going to go into. So this one, by default, it uses pip, and it's just like the default image. You can totally just use whatever image you want. You can use a Docker file to set it up. You can, in the Docker file, you can use Conda or whatever. So what I'm going to do is I'm going to show you how to use a project that's called repo2docker, which basically takes a GitHub repository and converts it into a Docker image that we can use with JupyterHub. If you already know how to use Docker files, that's great. You can just use those. But I think for a lot of people, they just want to have an environment.yaml file or something like that, and have that automatically do things. So I'm going to demo how we're going to do that. So I'm going to go back to my terminal now. Right, I have this one. So I'm going to use this repository. Where is this repository? Use this repository that I just pasted. This is the same one I was showing earlier about LIGO, the gravitational waves research. So if you go there, you will see that it has an environment.yaml file, which specifies a bunch of dependencies that it needs. And what we want is we want to build an image that has all of these dependencies. So I'm going to now go here, and I'm going to type Jupyter. I've installed Jupyter repo2docker. You can install it with pip. Jupyter-repo2docker. I'm going to give it the path to the GitHub repository. I'm going to give my image a name. I'm going to call it Yuvi Panda /ESIP test v0.1, and I'm going to ask it to not run it. I'll show you why that matters later. So what repo2docker does is it intelligently looks at a repository and then figures out how to build it into a Docker image without you having to specify a Docker file. So if it has an environment.yaml file, it'll just use Conda and set up all of the things you want from it with just Conda. So you can see it says using Conda builder. I've just highlighted that. And if you just had requirements.txt file, for example, it would instead just use virtualenv and pip. If you had, we are working on like adding, for example, like R. So if you have like whatever the equivalent of R's requirements.txt file is, it'll decide to use R kernel, and then it'll like set up all of the dependencies from there. You want to set this up for Julia, for NPM, and for things like that, so people can like instead of having to like figure out how to set up Docker files and how to make it work with Jupyter properly, you can just have an environment.yaml file, and it'll just work for you.
This is the part where, like, if this was a TED Talk where we'd stand up and applaud. That's awesome.
So while this builds, I want to show you why I had to pass no run earlier. So this is a different tab, but if you see here, I've run basically the same thing. I've done Jupyter repo Docker, HTTPS GitHub minrk Lego binder, and I have not specified no run. So what this has done is it's cloned everything, used Conda builder, installed all the things with Conda, and then it has actually started the notebook for me on my local computer. So I can go here. I can go here, and this is running. So this is set up to run as a Docker container inside my computer with the Conda setup that you have specified in that repository. And I didn't have to do anything else. I just had to I just had to do Jupyter repo Docker, and it knew that it was an environment.yaml file. It knew that it had to use Conda. It installed all of the things, and it showed you all the output. So if it failed for some reason, you'll be able to debug it, and then it just started it, so you can run it. So this is like repo Docker is a very useful thing for like a lot of use cases. We're just using it for one use case, which is build an image or use with JupyterHub. This requires that you have Docker installed, but it works fine on like OS X and Linux, and I think on Windows. We just haven't tested it because this is like fairly new. All of this is like happening very fast over like the last 2-3 months. Right. So this is still it's going to take a few minutes to build, I think, because Conda is slow and my network is saturated. So any questions? Felipe, I hope I'm pronouncing your name right. Does that answer your question?
I think he might be muted. Oh, there he goes. Yes.
Okay. Yeah. Cool. So yeah, we encourage people to use repo Docker instead of doing Docker files directly because it's simpler, and we will follow Docker file best practices on your behalf as they change, so you don't have to do that. I'm going to provide a link to GitHub to repo Docker in the chat.
Cool. And I don't know if the chat is captured in the recording, so we might ask you to provide those links, and we can put those like on the YouTube comments or something.
Yeah, I'll make my slides available as well, and I'll make sure that I put these links in the slides.
Yeah. Okay.
Yeah, so you can see now all the Conda stuff.
So just so right now you're building a container that you're going to use as sort of the base for the Kubernetes swarm, or?
No, this is just like what image you get as the user when you log in. So right now, when I'm logged in to so many notebooks, which one is this? This is the one. Yeah, if I'm logged into this one, this is a very specific build. It's also built with repo Docker, but it's built with a virtualenv, which I'm guessing not everyone would want to use. So if I do quick freeze, you will see that it is very bare bones. It doesn't have anything. Well, it has a bunch of stuff, but it doesn't have like no NumPy, for example. No NumPy or like anything that like are like very commonly used in a bunch of things. So well, I don't actually have to wait for this to build. I can just use an image that already exists. I already have built this before. I built a smaller image that's similar.
But you are building a sort of default container, though, right? For the.
Oh yeah, we are. Yeah.
Yeah. which is what Philippe was asking, right?
Yeah.
Okay.
Using an existing image. Right. This will have an example I can use. Right. So what I'm going to do now is, we have a JupyterHub that's set up and running, which is using some image that's the default. And now I want to say I want to use a very specific image that I have. So I'm going to change the config.yaml. And I'm going to say single user. Single user is like configuration for like what the user sees when they actually log in and create a server. And I'm going to say the image name is Berkeley ESIP single user date, which is like an image that we built earlier. For like our classes that has NumPy and a bunch of other stuff, and I'm going to call like the tag for that is v0.1. So when someone wants us to add a new library to everyone's image, what we do is we basically rebuild this image and then just update the tag. So I've changed the config, and now I need to apply this. So I'm going to do Helm list, which will tell me all the packages installed on the current Kubernetes cluster. And there's only ESIP demos installed, and it's installed as JupyterHub version 0.3.1 is installed as ESIP demo. So now I can do Helm upgrade ESIP-demo, and I need to provide the full path to the GitHub the chart again, which we will fix soon with the much more readable name, but until then, we need to I need to keep copy pasting the URL to places. And then -f config.yaml. And what this will do is it'll look at the current configuration of the JupyterHub, and then it'll look at the config that's in YAML, and then it'll do only the changes that are required. I'll show you what I mean by that in just a second when this is completed. So this is also, pulling the new image on all of the nodes. So it starts like, if it's a 2 gig image, you don't want it to be pulled each time the user starts it. So it gets pulled at installation time, but that means, of course, installation is like a little slower than usual. Yeah, this conda builder thing is done, but I'm not going to push that because we only have like 15 minutes left. But you get the idea. So if I do a get pod, you will see that we have restarted the hub because we've changed the configuration of the hub. We have asked it to use a different image. But we have not restarted the proxy. So let me actually set this to watch so you can see this better. So you can see that the proxy, which is what users first hit and it redirects them to the hub or to their own containers, has not restarted at all. So the users who are connecting will actually not notice a difference if they're already running there. And the hub config changed, so it's being restarted. So it only does differential deployments. It won't actually take down everything when you do whatever. Sorry. It sometimes takes like a minute because it's like detaching and attaching a disk, and it's also maybe like pulling a new image. If you're using an external database, it's much faster, but I'll just have to wait for this to get to running, which might be like another minute. During this time, new users can't log in, but if you're already logged in, you can keep using it and you won't actually see any disruption. So, like we're trying to eliminate like basically like a minute or 2 minutes of downtime whenever you upgrade, but it's kind of so far okay for us. It just requires that we use an external database, and we're like, we don't want to deal with the database right now. This is okay for us.
Now you didn't mention. Well, I guess you're running. Are you going to talk about authentication?
Oh, yeah. So I'm not going to demo authentication because it's just. But we have support for like Google, LDAP, GitHub, and writing your own authenticator is also very simple, and all of that is supported in the Helm chart. So I can show you the doc reference where we talk about it, and I can show you the kind of config that you would use. So here, for example, I don't know if you can, I'm going to just copy paste this into Vim. So if I was going to use Google OAuth, for example, I will just do this. Oops. So I say auth type Google, and then for Google I have all these settings I need to have.
Right.
Which is like, the secret and whatever. And if you're using LDAP, you'll do type LDAP, and then you would have like all these settings you need to have, like, which domain it is, what groups you want to allow, and if it's like GitHub, like you have a secret and whatnot. I didn't want to do that during this demo because, like the larger part of that is just like figuring out how your authentication provider works.
Okay.
And setting that up. But yeah, we do support in this a bunch of authentication providers, and it's very easy to add more.
Okay. And you can just do it through the Helm chart and...
Yeah, exactly. So like how we restart, when we did the Helm upgrade after the single user image, you can change the auth and do a Helm upgrade, and that will basically give you the new thing.
Yeah, cool.
Yeah, let me see if this is up. Yep. Yeah, it's up. So if I go back and go here and I log out, then I'm like, user 2, some password. I mean, no password really. And then I can see that user 2 is being created. So the first time it's created, a disk is actually created for them. If you're using OpenStack, this might provision a new Ceph disk or whatever, and then it's formatted and then it's being attached. So it takes like a while. But when it comes up, let's start my server, and this is a new user, but it's also a new image. So if I go here, like this one we have installed a NumPy and SciPy and things like that. So I can do please grab NumPy, and it has NumPy installed, right? So this is just made from, this is the Git repository that it's being made from, using repo Docker. It's user date, and if you see here, it's practically empty except for the fact it is a requirements.txt file that lists, like what you have here. And then we have the same environment in our JupyterHub. For authentication, I am going to show a very simple thing, which is right now it's a dummy authenticator. You can use any key, any value, but you can also set a password. You can say like everyone must use this common password that I just made up to log in. Otherwise, you won't be able to log in. So I'm just going to show that as an example of like the auth settings you can change, and the fact that I can just deploy this and it just works fine. So dummy password, okay, and then I can just do, I'm just doing the same command I did earlier, which is Helm upgrade, blah blah blah.
So the single user,
this will finish off, and then sorry.
The single user doesn't mean that only a single user is using it.
No, right. Sorry, we should probably rename that to just user. It's called single user for historical reasons. It's just what each user sees in their own thing. So if other people go to this URL, I'll take this down after the talk is over, but I can put it in the chat now. So if you go here, I mean, it might be down right now because I'm doing a deploy. But right after that, you can just get in there with any password. No, with the password is, specify the password. I forgot what I did. Yeah, if you can use the password like what. Once this goes away from container creating in like a minute, anyone can go in there and log in. So yeah, a single user does not mean only one user can access it. We might rename that to just say user at some point.
Yeah. And so when you do this get pod, you would you'd see different pods for each user.
Yeah. You can also Kubernetes also by default ships with things like you can like look at the logs of things. So if I want to see the logs of my proxy, I can just do kubectl namespace. Then logs is my verb, and the name of the proxy pod is my noun, and it shows me all of that, and I can do -f to follow it along. So if you're doing Docker, you would like have to either have like Elasticsearch or something like that, or you would have to like go SSH in and do your stuff. While with this, I can just do get logs from here. You can still you still want to use Elasticsearch for persisting logs, but to just get them, this is fine. And you can also like exec into it. So these are all just, I'm just now showing off random Kubernetes features.
Yeah.
So you can do things like this. And this is useful when, we are like debugging someone's work and like, I want to see what you're seeing. So now I'm SSH'd, basically SSH'd-ish into the same container that this person has. So if I do ESIP, now I'll see that, it's running a notebook process and my SH that's in the terminal and the bash that I executed from this. And I have access to that file system. So this is like almost in some forms like sudo, but more contained and nicer. And like there's a lot of other features of Kubernetes you can have. Like there is automatic Let's Encrypt integration that you can install, and then you just specify a domain name, and it automatically makes sure that you get an SSL certificate and keeps it up to date, and checks for it and stuff like that without having to do whatever. So there's like lots and lots of features that you don't have to you just get by baseline by just using Kubernetes. Okay, so it's running now. So if I go back again and log out, and then try to log back in with a random password, it says invalid username and password. And if I say what, then it logs me in. So I just changed how authentication works. And it's just, the dummy authenticator only has this option, but of course other authenticators have other options. And you can set that up for whatever.
That said, I guess if you wanted to set up with a HTTPS, you have some instructions somewhere for the.
Yeah, we have instructions for it on the JupyterHub guide. We are also we are also releasing a new version of it next week. I mean, it's the same, just incrementally working on it. But 0.4 of the guide, which should be out next week, has much easier support for including like automatic Let's Encrypt stuff. While right now we have to do it manually. Okay. But yeah, the reason I don't show it in demos is you need a DNS record for SSL to work, and it just doesn't happen in like it's just like too risky to have in like a 1-hour demo. Yeah. But yeah, we do have pretty good support for it.
So for like what's encrypt and all that.
Yeah. Automatic Let's Encrypt, but you can also specify your own SSL certificate if you need to do that for some other reason.
Sure.
But we recommend everyone to Let's Encrypt. So we have discovered that, for example, when we run workshops, a lot of people who feel competent enough to set this up don't actually feel, they've never registered a domain. They don't know what an A record is. So we want to make sure that there is a default option available for them. So that's why we just provision a raw IP by default. But yeah, for it to be like a fully functional production cluster that someone has to care about, we do make sure the SSL is very, very easy to add.
Cool.
So the other thing, okay, so we have only a few more minutes left, and I wanted to show you some of the other cool things that we are doing. So I'm not sure if you've heard of Binder.
Yeah. We love it.
So what we've done is we've basically rewritten the backend of Binder. So Binder is this amazing service that lets you convert any GitHub repository into like a running notebook. So it's very similar to Repo Locker-ish. But the old Binder, what we have done is we have redone it. So it was built on top of JupyterHub. It still has the same functionality. But what you'll be able to do is you'll be able to install a Binder for your own organization very easily. Because I think a lot of people like building images is like, I don't think sysadmins and like people who run clusters should have to deal with that. It's like too time consuming and it's inconvenient for everyone involved. So setting up a new Binder will just be an option in the Zero to JupyterHub guide. And for like people who haven't seen it, you can basically just I'm just going to keep using the minRK LIGO Binder demo because it's pretty cool. And I can just say like, yeah, launch the master of that for me. And open index.ipnd, and it'll launch it. And if because we had already built it, but if you're just building a new container, a new repository that we've not built before, you will see the build logs here, and if it succeeds, it'll launch it for you. And you can then convert that into a URL. So if I so this is the same LIGO Binder that you saw earlier running, and I can convert it into a URL. So I actually have a URL here. So if that's in my talk. So if I go here, right. Oh, nice. I did. I remember. I was like, oh, this Felipe name sounds familiar. So I gave a link I gave a link to the new binder URL, which basically lets you, like you go there and it like runs the LIGO stuff for you, and you can give this out to people. And this is now built on top of Zero to JupyterHub, which means it's really easy for people. So you just add like a bunch more config into your config.yaml file, and you'll have a binder.
Yeah, that's fantastic. I mean, that's another thing where we tried to get binder going for our organization and failed.
Yeah.
Yeah.
Yeah, we definitely want to make that easy. Like I remember we were discussing what we want binder to be in like 5 years, and we were like, we must have at least 100 installed binders in like random places across the world for people to use. Like there should not be just one MyBinder or ARM. So that's something we are taking very seriously. And the earlier Rapport Docker demo that you saw, so binder is using exactly that. So binder is basically just a UI, and then Rapport Docker, and then JupyterHub. So we are like reusing a lot of the stuff that already exists. So yeah.
Wow.
So I think we're out of time. That's the end of the demos that I had. I'm around for questions if people have more questions.
Yeah, I'm not sure if we're going to get cut off by another ESIP talk here on this GoToMeeting, but just in case, I just want to say thank you so much. That was super clear, and I think it's going to be easily reproducible by folks along with the documentation that you have. And hopefully it'll convince people that this is pretty straightforward to do, and man, that Helm stuff is amazing. And I just wanted to thank you too, as Philippe did in the chat there, for the wonderful stuff that the Jupyter team is doing for the community. You guys in Berkeley there and the rest of the groups. I mean, it's really transforming our ability to do science easily, I think, and make reproducible science. It's fantastic.
Yeah, I wanted to just mention that it's not all just me. That is Vin RK, Carol Willing, Chris Holgraf, Ryan Lovett, lots and lots of people who are involved in like making this situation a lot better than it used to be. So yeah, you can email me or find us on Gitter for more questions and whatnot.
Okay. Awesome.
But otherwise, for more time. Yeah.
Yeah. Okay. Thank you so much, Yuvi.
Yeah. Thank you for having me.
All right. We look forward to seeing the recording on YouTube. I'll send that out to everybody.
Yeah.
All right.
Thank you.
Bye-bye. Thanks, everybody.